Hi, my name is Tim Milburn. I'm the proud owner of a 2014 Chevy Volt. It's a plug-in hybrid electric vehicle, which means it can handle either electricity or gasoline power, so there's no range anxiety. Normally I plug in and I drive electric miles as much as I can, mostly because it's about 20% of the cost of a gasoline mile, and it provides zero tailpipe emissions from the vehicle. But I still do sometimes exceed the 35 miles and have to use the gasoline. Since I got my EV, I've been using this standard J1772 charge coupler. It's a standard from the Society for Automotive Engineers, or SAE, and this is a level 1, which means 110 to 120 volt charge. So it basically comes out of the household current. And what I do to charge is I unwrap the cord. And then I go over to the vehicle and I open the charge port and I plug the connector in, and the charging begins automatically. For this one, for the 35 miles range for the Volt, it takes about 12 to 16 hours to charge on household current. So now I'm no longer going to be using the corded charger. I'm going to be using my new Plugless charger, which uses an inductive current. It's introduced you to components. This is called the control panel. It's wired to house current. And then on the ground over here, we have what's called the parking pad. And there's a third component that will be on the car, underneath in the back. It's called the vehicle adapter, and I'll explain all these in a minute. Inductive charging uses an electromagnetic field to induce electricity to recharge the EV batteries instead of strictly conducting electricity through wires. The nature of electricity is such that an EMF is created as electricity passes through one set of copper coils in the parking pad, and it induces electricity to flow in a mated coil mounted on the vehicle. It's the same principle you've seen in an electric razor or a toothbrush or a cell phone. Okay, what we want to do next is show you the final position of the charging. This is the charger actually in charging process, and you can see the unit is plugged into, in this case, an outlet. In most cases, this would be hardwired to a 240 circuit in the house. So this is where the power comes from and is managed. So now we're going to go around to the back of the vehicle. So now we're at the back of the car, and you can see down here is the parking pad, which we saw a second ago. And above it is what's called the vehicle adapter. And basically you've got an EMF that's induced in the parking pad, which communicates through an air gap of about 4 inches, if you can see my hand, and starts a current flowing in the vehicle adapter coil, which charges the EV's battery. It's a very safe and effective way of conveniently charging the vehicle. You'll also notice that the parking pad is roughly centered left to right on the vehicle, and also underneath the two coils are basically centered over each other so they can transmit the electricity. To illustrate this, we're showing an image of an electromagnetic field, or EMF, from the transmitting coil to the receiving coil, and the power comes in through the transmitting coil as a generated current, and it will induce the current through the EMF and create a current to flow in the upper receiving coil, which then will power the EV's battery. This illustrates how the power flows from the electric service panel with the circuit breakers into the control panel. In this case, it's at 240 volts or level 2 from the house. And it goes from the control panel then next into the parking pad. And from the parking pad, it will then create this EMF, which will induce a current on the vehicle adapter, which will then charge the battery. And then we're overlaying the EMF effect on the two coils. So you can see how that looks. To give you an idea of what it looks like, this is the vehicle adapter as it comes out of the box, and then showing it from underneath, a couple of views, and then also how it connects to the cabling that goes up to the front of the vehicle. The plugless system uses the SAE standard J1772 communication protocols for EVs and emulates the corded charger in terms of the logic of the EV's charging and communication of the plugless unit to the EV's onboard charger. The plugless system wirelessly communicates from the control panel to the EV and its power management system via the vehicle adapter. Cables hardwired from the vehicle adapter to the EV control the logic and work with the onboard charger to provide safe control of the charging process. Okay, next I want to show you just the charging event as a daily routine, what happens. So basically we're going to start the vehicle, and this is, I'm approaching my home and getting ready to charge. I'm going to open my garage door and start driving into the garage to park and charge. So basically this is really easy because the unit communicates with the vehicle. It knows where it is, it knows where the vehicle adapter is, so it's going to position the car through the guide arrows so that I'm in the right spot when I finally stop. And the arrows go at a certain pace, and when you get closer they slow down a little bit, and then eventually you'll be in the right spot and the green ring will show up and it says you're ready to charge. So I'm in position, and then the next thing we want to see is I turn the car off, and you'll notice up on the dash the car is now doing a handshake, and when the green light goes on, the charging has started, and the blue ring tells you it's charging too. Okay, I've backed the car away from the control panel. I want to give you another perspective. So the cord is basically running along the garage floor to the parking pad. They do provide cord covers to minimize any tripping hazard. But I want to show you what's under the hood of the Volt. The process of charging starts with the charge port on the vehicle. And in fact, the electric vehicle adapter is hardwired to this port underneath and feeds the current from the vehicle adapter into the same circuit, basically piggybacks it, and goes into this device here, which is the onboard charger or inverter, which inverts the alternating current to direct current, which is what's needed to charge the battery. And while we're in here, you can kind of see down here, this is what is the electric motor, and over here this is the top of the gasoline engine. And when the EV battery runs down, the gasoline engine automatically comes on to continue to recharge the battery, which continues to power the electric motor. This inverter is a 3.3 kilowatt converter, which means for level 2 charging it will take about 3 or 4 hours from empty to refill the battery. This would be the same amount of time whether this were corded or plugless, because the inverter itself basically controls the pace at which the charging occurs. And in this case, this plugless system is also a 3.3 kilowatt device as it's mated to this onboard charger. If this were a Nissan Leaf instead, the inductive power level would be twice that of the Volt, or 6.6 kilowatts, which matches the onboard charger of the Leaf. This means that the Leaf, which has about twice the distance capacity and twice the power of the Volt, would charge in about the same amount of time as the Volt, or about 3 or 4 hours from empty. Also, with plugless charging, I just get out of my car once parked and go. There's no stopping to unwind cords or plugging in. I have no excuses to not plug in, such as my hands are full, it's raining, I'm tired. So the result is I'm charging more frequently and go to the gas station less. The end result for this, I think, will be I will drive more electric miles and spend no time plugging in at home or dealing with the cords and connectors. I want to thank my wife Tracy for helping out as a camera operator, and if anyone has any questions, please feel free to email me, Tim Milburn, and I'd be glad to answer your questions. Thank you.